Hey everyone, and welcome to another deep dive.
It's great to be here.
Today we're going to be talking about space exploration and technology,
A topic that's not just fascinating.
but also really relevant for anyone prepping for those UPSC exams.
Oh, absolutely.
But even if you're not,
Even if you're not taking the UPSC exams.
if you're just someone who wants to learn more about the universe,
A curious mind.
we've got some mind-blowing stuff in store for you today.
We really do.
I'm excited.
I am too. We're going to be covering everything from black holes to India's amazing space program.
And to help us connect all the dots,
Yeah, and to make sense of it all.
we have our expert here.
Happy to be here.
So let's start at the beginning,
Okay.
the Big Bang.
The Big Bang, the event that started it all.
So 13.8 billion years ago,
Roughly.
all the matter in the universe was just crammed into this tiny, hot, dense point.
Yeah. And then,
No.
well, not exactly an explosion.
Right. It's more like
More of an expansion.
an expansion.
Yeah.
The fabric of space itself stretching out.
And it's still going on today.
So as the universe expanded and cooled down,
The first elements started to form
hydrogen.
hydrogen, helium, the simplest ones.
And then over billions of years,
Gravity started to pull these elements together.
forming stars.
Stars, galaxies.
It's incredible to think about.
It really is. It's mind-boggling.
And then there's this whole other part of the universe
We can't even see.
that we can't see.
Dark energy,
Dark matter.
dark matter.
Exactly.
These mysterious forces that make up the majority of the universe.
And we know they're there.
Because we can see their effects.
We can see how they influence the movement of galaxies,
The expansion of the universe.
but we still don't know exactly what they are.
It's one of the biggest mysteries in cosmology.
So from the vastness of the universe,
Yeah, let's zoom in a little.
let's talk about something much smaller, but just as mind-blowing.
Okay.
The God particle.
Oh, yes. The Higgs boson.
This tiny particle that gives mass to other particles.
Without it, we wouldn't exist.
The universe wouldn't exist as we know it.
Exactly. The Higgs boson was a missing piece of the puzzle.
Of the standard model of physics.
Right.
Could you explain what that is for our listeners who might not be familiar with it?
Sure. So the standard model is like a framework that describes all the fundamental forces and particles in the universe.
So it's kind of like the rule book for the universe.
You could say that. And the Higgs boson was the last particle predicted by the standard model to be discovered.
And it was discovered.
It was in 2012 at the Large Hadron Collider.
The LHC.
Yes, they basically smash particles together at incredibly high speeds.
And from that, they were able to confirm the existence of the Higgs boson.
Pretty amazing.
Truly remarkable.
And the LHC is still going strong,
Still searching for new particles.
trying to unlock the secrets of the universe.
Now let's move on to another mysterious particle,
Okay.
the neutrino.
These guys are fascinating.
They're practically massless,
Almost.
and they rarely interact with matter
Yeah, they can pass right through us.
through the entire Earth.
What if we're not even here?
But they can tell us a lot about the universe,
Yeah, about supernovae.
about the structure of the Earth.
Even about the early universe.
And India is actually at the forefront of neutrino research.
With the INO.
The India-based Neutrino Observatory,
An incredible underground laboratory.
designed specifically to study neutrinos.
It's a really exciting project.
Okay, so we've talked about the building blocks of the universe.
Now let's talk about something a little bigger.
Stars.
Stars, the engines of the universe.
They're born in these massive clouds of gas and dust,
Nebulae,
right? And they shine because of nuclear fusion,
where hydrogen atoms fuse to form helium,
releasing enormous amounts of energy.
which we see as light and heat.
And stars have these fascinating life cycles.
They do. Depending on their mass, they can end up as
White dwarfs,
neutron stars,
or even black holes.
the most extreme objects in the universe,
Black holes are regions of space-time,
where gravity is so strong that nothing can escape,
not even light.
which is why they're called black holes.
Right. So how does a star become a black hole?
Well, it all comes down to mass.
There's this thing called the Chandrasekhar limit.
Right. Named after the brilliant Indian astrophysicist Subrahmanyan Chandrasekhar.
If a star's core is below this limit,
It'll end up as a white dwarf.
but if it's above the limit,
It can collapse into a neutron star or a black hole.
it's amazing how the life and death of stars shape the universe.
They create the elements that make up planets.
And even us.
It's all connected. predicted.
And speaking of black holes,
Did you know that in 2019,
we got the first ever image of a black hole.
it was incredible.
The Event Horizon Telescope.
A global network of telescopes.
Working together to capture this groundbreaking image.
It was a huge achievement.
And it confirmed a lot of what Einstein predicted about gravity.
Speaking of Einstein,
He also predicted something else pretty mind-blowing.
gravitational waves.
These ripples in the fabric of space-time.
Caused by the acceleration of massive objects.
Like colliding black holes.
Exactly.
Uh-huh.
And it wasn't until 2015.
That we actually detected these waves.
Thanks to LIGO.
The Laser Interferometer Gravitational Wave Observatory.
Another incredible scientific achievement.
Now let's bring things closer to home.
Our solar system.
Our cosmic neighborhood.
A place full of wonders.
Planets, moons, asteroids.
Even these things called planets.
Planets. What are those?
They're basically moons that have escaped their planets.
Really? So they're just wandering around the solar system.
Pretty much.
Yeah.
And then there are exoplanets.
Planets orbiting other stars.
We've discovered thousands of them.
And some of them might even be habitable.
It's an exciting time to be studying exoplanets.
But before we get ahead of ourselves,
Right. Let's clear up some confusion.
about those space rocks we hear about all the time.
Asteroids.
Meteoroids.
Meteors.
Meteorites.
It can get confusing.
So let's break it down.
Okay, so asteroids are the big guys,
The rocky bodies orbiting the sun.
and when a piece of an asteroid breaks off,
That's a meteoroid
and if a meteoroid enters Earth's atmosphere,
and burns up,
that's a meteor.
or shooting star,
And if it survives the trip through the atmosphere,
and hits the ground.
that's a meteorite.
Okay, I think I got it.
Good.
Now, from rocky asteroids,
To icy comets.
these are often described as dirty snowballs.
They're made of ice, dust, and rock
And they have these really elongated orbits,
that take them close to the sun.
and then way out to the outer solar system.
And as they get close to the sun,
They heat up.
and they create those spectacular tails.
It's amazing.
It is, but all this activity in space.
That creates a problem.
Space debris.
This debris can be natural,
Like pieces of asteroids or comets.
man-made,
Like old satellites and rocket parts.
and it's becoming a real hazard.
It can damage spacecraft.
And there's this scary scenario called the Kessler syndrome.
where a chain reaction of collisions could make near-Earth space unusable.
That's a real concern.
It is. Luckily, ISRO
India's space agency.
has developed a system to track and monitor space debris.
It's called Project Nitris.
It's a really important initiative.
So let's talk more about ISRO,
Okay.
the Indian Space Research Organization.
Established in 1969,
It's been responsible for some incredible achievements.
from launching India's first satellite
Aryabhata
to sending missions to the moon,
and Mars
ISRO has really put India on the map.
as a major player in space exploration.
Absolutely.
And India's launch vehicle technology has come a long way too.
From the early SLV and ASLV
To the workhorse PSLV,
and the powerful GSLV.
ISRO is constantly innovating
And they're also working to encourage private sector participation in the space sector.
through organizations like InSpace and NSIL.
It's an exciting time for India's space program.
It really is.
So now that we've covered the basics
Let's dive into some of the specifics
of India's space missions,
and the different types of orbits
because choosing the right orbit,
is crucial for a successful mission.
it is.
So stay tuned.
We'll be right back after a short break. Yeah, it really is a testament to ISRO's ambition and growing expertise.
So let's talk about Chandrayaan first, India's lunar exploration program.
It's been a huge success.
Chandrayaan-1, back in 2008,
Yeah, that was a groundbreaking mission,
it discovered water molecules on the moon.
which was a huge discovery.
It really changed our understanding of the moon,
And then Chandrayaan-2,
which faced some challenges,
with the lander,
but the orbiter's still going strong.
collecting valuable data.
And now we're all waiting for Chandrayaan-3.
Another attempt at a soft landing,
It's going to be exciting.
for sure.
And then there's Gaganyaan,
India's Mars orbiter mission,
launched in 2013,
and successfully reached Mars orbit in 2014
making India the first Asian nation to do so.
on its first attempt.
An incredible feat.
It really showed the world what ISRO is capable of.
And of course, we can't forget about Gaganyaan.
India's human spaceflight program,
The goal is to send Indian astronauts into space,
a truly ambitious goal.
but ISRO is making steady progress.
They've been developing the necessary technologies,
The crew module,
the escape system,
the launch vehicle,
and they've even introduced Via Mitra
a humanoid robot.
to test the spacecraft's life support systems.
Amazing.
It's really incredible to see how far India's space program has come.
And they're not stopping there.
No, they have even more ambitious plans for the future.
Like missions to Venus
Chandrayaan,
and the Sun.
DRDO.
These missions will help us understand our solar system even better.
And they'll push the boundaries of scientific exploration.
But it's not just India that's making strides in space exploration.
Right. There are so many other countries and agencies doing amazing work.
Like NASA,
With the Artemis program.
aiming to return humans to the moon.
And establish a sustainable presence there.
And China, with its Change program.
They've already landed rovers on the moon.
And they're planning a lunar base.
The European Space Agency has missions to Mercury and Jupiter's moons.
And then there are private companies like SpaceX.
Making space travel more accessible.
It's really an exciting time to be following space exploration.
It is. There's so much happening.
So many discoveries being made.
And it's all thanks to these incredible telescopes and observatories.
Like the Hubble Space Telescope.
Which has given us breathtaking views of the universe.
And the James Webb Space Telescope.
Its successor,
even more powerful.
Designed to see further back in time.
To the early universe.
And then we have ground-based telescopes.
Like the 30-meter telescope.
XAMT.
And India's giant microwave radio telescope.
GMRT.
All these instruments are helping us unlock the secrets of the cosmos.
And answer some of the biggest questions about our universe.
But as we explore space further,
it's important to remember
that our actions have consequences.
We need to be mindful of planetary protection.
Making sure we don't contaminate other worlds.
Or bring back harmful organisms to Earth.
And we need to be responsible stewards of space.
Ensuring its sustainability for future generations. Between exploration and preservation.
But ultimately,
space exploration is about pushing the boundaries of human knowledge.
Expanding our horizons.
And inspiring future generations.
It's about understanding our place in the universe.
And our responsibility to it.
And I think that's a really important message.
I agree.
So we've talked about all these amazing things happening in space, but how does it all actually affect us here on Earth?
That's a great question, because sometimes it feels like space is this distant realm, but it actually plays a crucial role in our everyday lives.
I mean, yeah, we rely on satellites for so much.
Absolutely. Communication, navigation, weather forecasting.
GPS on our phones, live television broadcasts.
Monitoring natural disasters, tracking climate change.
It's incredible to think about.
And the impact goes even further. Space exploration has led to so many technological spin-offs that have benefited various industries.
Like what kind of spin-offs?
Well, for example, lightweight materials used in aircraft and sports equipment. Those came from space research.
Wow, I didn't know that.
And medical imaging techniques, even freeze-dried foods.
It's amazing how space exploration has touched so many aspects of our lives.
And as we continue to explore, we're opening up new possibilities for resource utilization.
Like mining asteroids.
Exactly. Asteroids contain vast amounts of precious metals and minerals.
Which could help address resource scarcity on Earth.
And potentially pave the way for sustainable space exploration.
It's fascinating to think about the potential.
But amidst all this excitement, it's important to remember that none of this would be possible without the incredible people behind these missions.
The scientists, engineers, technicians, and support staff.
Absolutely. They're the unsung heroes working tirelessly, often behind the scenes, to push the boundaries of human ingenuity.
Facing challenges, setbacks, but driven by a shared passion for understanding the universe.
And of course, we can't forget the astronauts, the brave men and women who risk their lives to venture into the unknown.
They endure grueling training, face harsh conditions, and push the limits of human endurance.
They're true pioneers, inspiring generations with their courage and determination.
As we look to the future of space exploration, we can be certain of one thing.
There will be more incredible stories to be told, more challenges to overcome, and more discoveries that will amaze and inspire us.
It's an exciting time to be alive, witnessing the unfolding of this cosmic drama.
And for those aspiring to be part of this grand adventure, remember the knowledge we've shared today is not just about understanding the universe, it's about understanding our place within it and our responsibility toward its future.
We've covered a lot of ground today, from the Big Bang to black holes, from India's ambitious space program to global efforts in exploring the cosmos.
We've delved into the scientific marvels, the technological advancements, and the ethical considerations that come with venturing beyond our planet.
It's been an incredible journey, and we hope this deep dive has ignited your curiosity and inspired you to continue exploring the wonders of space.
Remember, the pursuit of knowledge is a journey without end.
So keep looking up at the stars, keep asking questions, and keep dreaming big.
Because the universe is vast and full of mysteries waiting to be unraveled.
Thank you for joining us on this deep dive into space exploration and technology.
It's been a pleasure exploring the cosmos with you.
And remember to stay curious.
And keep exploring.